Welcome to my YouTube channel. In this video lecture, we are going to answer questions of great circles from 𝐃𝐞𝐻 General Navigation book. So far we have solved 60 questions. In this video lecture, we are going to start solving question 61 to question 70. So let's start question 61. A great circle track joins position alpha and bravo. What is the difference between the starting great circle track and the destination great circle track? So we know that by definition, convergency is nothing but the difference. Convergency is the difference between two great circle tracks. Is the difference between two great circle tracks. Now these 2 points are in the south hemisphere. 57 south, so let's say this is your prime meridian, 0 degree. This is your equator. Okay. Now 57 south will be here, point A. 57 south, 140 west. Point B will be here, 63 south, 150 west. We are traveling from A to B. Now since we are in the south hemisphere, the great circle will be like this. Okay, so rhumb line, great circle. So let's find out convergency value. Convergency here is D long, so 140 west, 150 west, 10 degree into sine of latitude. So we have two different latitudes here, 57 and 63. The average of that will be sine 60. So 10 sine 60 into 10 will be 8 degree 39 minutes. 8 degree 39 minutes or approximately 9 degrees. Right? Now remember the DIID table. DIID table states that if you are in the south hemisphere and you travel in the westerly direction, your great circle track will increase. DIID. So if you are in the south hemisphere, travel westerly, the great circle track increases, meaning the great circle track at departure will increase by the value of convergency when you reach your destination Bravo. That means the great circle track at destination will be more than the great circle track at departure A by a value of convergency. By convergency 9 degrees. Okay, so it will be increase. What is the difference between great circle track at A and B? Increase by 9 degree. Okay, next. Position A and B are given. Distance between them is given. B is to the east of A. What is the longitude of position A? So, this is your prime meridian, 0 degree. B is to the east of A and B ka longitude is 50 degree 15 minutes east. 50 degree 15 minutes east. A can be in the eastern hemisphere itself or it can be totally in a complete different hemisphere, that is in the western hemisphere. A. We'll find that out. So let's find out D long. Now rhumb line distance equals to D long in minutes into cos of lat. So 280 nautical miles divided by cos of 45 equals to D long in minutes. That is equal to 280 divided by cos 45, 395.9 or 396 minutes. 396 minutes divided by 60 is 6 degree 35 minutes. That means the D long, the difference between the longitude of Bravo and longitude of Alpha is only 6 degree 35 minutes. That means position A will be in the same hemisphere as position Bravo, eastern hemisphere. Okay. How do you know that? See, the longitude of Bravo is 50 degree 15 minutes east. 50 degree 15 minutes east. Now the difference between your prime meridian 0 degree and 50 degree 15 minutes is how much? The difference is 50 degree 15 minutes, right? Now if the d long that we have found out just now were to be more than 50 degree 15 minutes east, then our position A would fall in western hemisphere. Okay, because the difference is more than 50 degree 15 minutes east. Okay, but now the difference is less than that, so we are certain our point alpha is in the eastern hemisphere. So longitude of alpha equals to longitude of Bravo minus d long. Longitude of Bravo is 50 degree 15 minutes minus d long 6 degree 35 minutes. So 50 degree 15 minutes minus 6 degree 35 minutes is 40 degree 43 degree 40 minutes east. So longitude of alpha is 43 degree 40 minutes east. A Lambert's conformal conical chart has a constant of the cone 0.85. Initial course of a straight line track drawn on this chart from point A to point B is 0.43 and at point B it is 0.55. So the great circle track at point A is 0.43. Great circle track at point B is 0.55. Now the difference between two great circle tracks is called convergency. Is called convergency. Okay. So we have to find the longitude of Bravo. Convergency equals to d long. What is the difference between them? We do not know yet. D long in degrees into sine of latitude. So convergency 43 and 55 is 12 degrees. Sine latitude. Latitude both uh, yeah. So sine latitude. So sine latitude is 0.85. They have given the constant of cone 0.85. Constant of cone is nothing but another term for sine of latitude. Okay, so d long in degrees. So 12 divided by 0.85 will be equal to 14 degree 7 minutes. 14 degree 7 minutes or approximately 14 degree. Now, you are flying from point A to point B in a direction of 0.43. So, point A to point B in a direction of 0.43. That means you are flying in the northeast direction, which means point A is to the west of Bravo. Point A longitude is 50 degree west. 50 degree west. Point B longitude will be more less than 50 degree west. By what value? By a value of D long 14 degree. So 50 minus 14 is equal to 36 degree west. Okay, so the longitude of Bravo is 36 degree west. Option Bravo. Next. What is the great circle track from 70 south 35 west to 70 south 60 east? So 35 west will be in the western hemisphere. 65 east will be in the eastern hemisphere. You are traveling from A to B. Great circle track will be like this. Since it's in the south hemisphere, the great circle will pass to the nearest south pole. Now we have to find the great circle track at the starting position. Rumline track at A is 090. Great circle track at A will be rumline track plus convergency angle. So 090 plus convergency angle. What is convergency here? Convergency here is D long. So 35 west plus 65 east 100 into sine 70. So sine 70 into 100 is 93 degree 58 minutes or 94 degree. Convergency angle will be half of that, that is 47 degrees. Okay, so great circle track will be equal to 090 plus 47. So 90 plus 47 is 137 degrees. Okay, next. So this is 0 great circle track is rhumb line plus this convergency angle. Next. What is the longitude of position 15 miles east of 58 degree 42 north 94 degree west? So this is your prime meridian 0 degree. This is 94 degree west, and the position is 15 nautical miles to the east of this, in somewhere here. Okay, somewhere here. So let's find out rhumb line distance. Rhumb line distance equals to d log in minutes into cos of lat. D long 15 nautical mile divided by cos of latitude is 58 degree 42 minutes. 58 degree 42 minutes. So 15 divided by cos 58 degree 42 minutes equals to 28 degree or 29 minutes. Okay, so 0 degree 29 minutes. Therefore, the longitude of, let's say this is your alpha, so longitude of Bravo is longitude of A, which is 94 west, minus the d long between them. Since you are in the western hemisphere and you are flying easterly, the values of longitudes will decrease. So 94 west minus 0 degree 29 minutes. So 94 degree minus 0 degree 29 minutes is 93 degree 31 minutes west. 66. Now, the INS position of the departure aerodrome 45 degree 32.7 minutes north, 139 degree 46 minutes west are input instead. So, correct coordinates are this. These are the correct coordinates. Instead of putting that, you have put this coordinates. You have put the correct latitude, but instead of putting or inserting 139 degree east longitude, you have entered 139 degree 46 minutes west longitude. Now, when your aircraft subsequently starts flying and it passes point 52 degree north, 180 degree west, what will be the longitude shown? Now, if at the beginning you put the wrong longitude value, so as it start flying, all the longitudes value shown to you will be also false, will be also wrong, correct? And it will be wrong by a fixed amount. So, what is that amount? See, the magnitude of the error, magnitude of the error is equal to input longitude. What is the input longitude that you have entered? Input plus output. So the difference between the longitude you have entered and the correct longitude is the magnitude of error, is how big that error is. So 139 degree 46.3, 139 degree 46.3 minutes plus 139 degree 46.3 minutes east. Add that 6.3 minutes. So that is equal to 279 degree 32 minutes. This is how big the error is. Okay. Now step number 2, you are passing a position which is 180 degree west. When you pass 180 degree west, the longitude shown will be different by 279 degrees 32 minutes. Okay, so now this error is in terms of west because the correct longitude is easterly, but you have put the western longitude. So the magnitude of error is westerly, towards the west. So what will be the longitude shown to you? It will be equal to 180 degree. It will be 180 degree plus 279 degree 32 minutes west of 180 degree. This. So you will have to add. So 180 degree plus 279 degree 32 minutes is 459 degree 32 minutes. Okay. 459 degree 32 minutes. Now we do not have 459 degree longitudes. We have 360, 180 in the western hemisphere, another 180 in the eastern hemisphere. So subtract this by 360 degree. So when you subtract 459 degree 32 minutes minus 360 degree, the longitude you get is 99 degree 32 minutes west. So when you fly 180 degree west longitude, the longitude shown to you will be equal to 99 degree 32 minutes west. So I'm going to draw this. This is your longitude diagram. North Pole, prime meridian, 180 east and west meridian, 90 east, 90 west. Okay, so when you're flying this 180 degree west longitude, what is the error? Error is equal to 279 degree 32 minutes westerly. Now westerly directions are clockwise. Okay, so when you add 279 degree, that much error, to this 180 degree, you get a value of 459 degree 32 minutes. 459 degree 32 minutes means this complete 360 degree. Okay, and plus additional 99 degree. Okay, additional approximately 99 degrees. So it will be equal to, you will find that position in the western hemisphere. Okay, that's why you have subtracted 360 degree and you will be left with 99 degree. Next, aircraft lies in the position. Aircraft lies in the position following drumline tracks. It starts from 4 degree north, 30 degree west, and then it flies south, east, then again north, then again west. What is the final position? Okay, so this is your equator, let's say. Your current position is 4 degree north, 4 degree north, 30 degree west. 4 degree north, 30 degree west. You are flying 700 miles south. You are flying 700 nautical miles south. So when you fly along a fixed longitude and you change from one latitude to another latitude, you are flying a great circle track. So great circle distance equals to d lat into 60. You are flying 700 nautical miles. Divided by 60 is d lat. 700 by 60 is 11 degree 40 minutes. So the change in latitude between the initial position and final position is 11 degree 40 minutes. Now what is the d lat between this position and equator? It is equal to 4 degrees. Total d lat is 11 degree 40 minutes. So 11 degree 40 minutes may say, when you subtract 4 degree, you are left with 7 degree 40 minutes. So remaining 7 degree 40 minutes will be traveled in the south hemisphere. So your new position will be 7 degree 40 minutes south hemisphere. Longitude remains same, 30 west. Now from here you are going to travel easterly direction. You are going to travel 700 miles east. Now when you travel along a fixed latitude, the latitude will remain the same. So we are going to write 7 degree 40 minutes south here. Longitude will differ. So let's find out the longitude. Drumline distance equals to d long in minutes into cos lat. So 700 divided by cos 7 degree 40 minutes equals to 706 minutes divided by 60, that is equal to 11 degree 46 minutes. Okay. So initial longitude is 30 west. You are in the western hemisphere and you are flying easterly. So you are going to subtract 30 degree. So you are going to do the subtraction. 30 degree minus 11 degree 46 minutes, 18 degree 13 minutes, 18 degree 13 minutes west. You fly 700 miles north again. So your new position will be the same. Same longitude 18 degree 13 minutes west. Latitude will also be the same, 4 degree north. You will come back to your original position. From here you are traveling 700 miles west. 700 miles west. So find out drumline distance again. Drumline distance will remain the same, but d long will differ. D long here will be different. D long at 7 degrees south latitude will be different from the D long at 4 degree north latitude because of the convergency of meridians. Now the convergency at 7 degree will be more than convergency at 4 degree north latitude. Okay, so that's why we are doing it again into cos that. But for great circle we did not repeat this formula. Why? For great circle we do not have the concept of convergence. We have concept of convergence only between two longitudes, not between two latitudes. So 700 divided by cos of 4 equals to d long in minutes. That is equal to 701 degree. That is equal to 701 minutes 42 seconds, or approximately 702 minutes. Okay, divide this 701 degree 42 seconds by 60, you get 11 degree 41 minutes. 11 degree 41 minutes. So your new position, new longitude will be 18 degree 13 minutes. New longitude will be, you are in the western hemisphere and you are traveling westerly. So old longitude plus d long. So 18 degree 13 minutes plus 11 degree 41 minutes. So 29 degree 54 minutes. 29 degree 54 minutes west. Very close to 30 degree west, but still a few minutes off. So 29 degree 54 minutes west. Which of the following differences in latitude will produce the greatest difference between initial great circle track and mean great circle track? Mean great circle track is nothing but drumline track between two points which are separated by 15-degree change of longitude. Now the difference between great circle and drumline is nothing but convergency angle. Convergency angle is half of convergency. That means this difference depends on convergency and convergency depends on sign of latitude, right? So let's find out the convergency for every option, and we will check that option which is the highest. 30 degrees south and 25 degrees south. So convergency here will be D long. D long is 15 degree. Sine latitude. Now the latitude here will be 27.5 average. So 15 sine 27.5 into 15 is 6.9 degree or approximately 7 degree. 30 south, 30 north is inapplicable, different hemisphere. 60 north, 60 south also inapplicable. 60 north, 55 north here. Convergency will be 15 into sine of 57.5. So sine 57.5 into 15 is 12.6 degrees. So correct answer will be option Charlie. Greatest difference is produced by these two latitudes. Okay, 12 is more than 7. 69. What is the final position after following the following these tracks? You start from 60° north, 30° west. You fly south for 360 miles, then east, then north, back to west. Okay, so let's do it. This is your Earth. So your initial position is 60 north, 30 west, and you are flying south for 360 miles, only 360 miles. So great circle distance is d lat in degrees into cos into 60. So distance is 360 divided by 60 in equals to d lat in degrees. So 360 divided by 60 is 6. So 6 degrees. So your final position will be 60 north minus 6 degree d lat, which will be 54 north, 30 west. From here you fly for another 360 miles east. So use rhumb line. Rhumb line distance equals to d log in minutes into cos lat. 360 divided by cos of 54. 360 divided by cos 54 is 612 minutes 28 seconds. Divided by 60 is 10 degree 12 minutes. So your new longitude will be 30 west minus 10 degree 12 minutes, which is equal to 19 degree 47 minutes west. From here you travel north again for the same distance. So your latitude will be the same, 60 north again and 19 degree 47 minutes west. Now from here you travel another 360 miles to the west. So great circle distance will be, rhumb line distance will be d long cos latitude, correct? So 360 divided by cos of latitude, cos of 60 equals to d long in minutes. So 360 divided by cos 60 is 720 minutes divided by 60 is 12 degree. So your new longitude will be 19 degree 47 minutes plus 19 degree 47 minutes plus 12 degree is equal to 31 degree 47 minutes west longitude. 31 degree. So 1 degree 47 minutes beyond 30 degree west. So your final position will be somewhere here. Here. Okay, because of the convergency of meridians, you have exceeded this 30 degree west longitude. Convergency at 60 degree north will be more than convergency at 54 north. Okay, next. The great circle bearing of Bravo from Alpha is what? Both are in the south hemisphere. So Bravo is in the east, Alpha is in the west, great circle track at A will be Rumline track at A plus convergency angle. What is the Rumline track at A? Rumline track at A is 090. You're going from A to B 90 degree. What is the convergency angle? Convergency angle is convergency D long, which is 50 degree east, 30 degree west, so 80 degree. So convergency is D long, which is 80 degree, into sine of latitude, sine of 70. So 80 into sine 70 is equal to 75 degree, 10 minutes. So convergency angle will be 37 degree, 55 minutes. So great circle track will be Rumline 090 plus 37 degree, 35 minutes, or approximately 38 degree. So that will be equal to 127 or 128 degrees. Select that option which is closest to this value. Then we'll stop here. We'll do the next 10 questions in the next video lecture. Practice all the questions we have solved so far. All the best.